So in this video, we're going to talk about searching algorithms. And the whole point of a searching algorithm is to search through a list of data to see if an item you're looking for is there, basically. So it'd be equivalent of being on, I don't know, a website, and you type something into a search bar, and it will then give you the result and tell you whether what you're looking for has been found or not. So we look a little bit at the spec. You need to understand how a linear search works, how a binary search works, and then basically compare the two, talk about kind of the differences between them, okay? So let's start by just explaining what they do, and then we'll move on to some kind of past paper questions. So to start with, let's look at a linear search, okay? Now, the way I like to envision a linear search is like having a shuffled deck of cards. So you've got a deck of cards, you shuffle them up, and then you say, right, let's find me the ace of spades, for example. And what you do is you start at the top of the deck, and you turn each card over one at a time, working through the whole deck until you either find the card you're looking for, or you get to the end of the list, or the end of the deck in this case, and find it's not there. So a linear search basically starts at the beginning of the list and works the way through. So let's look at this example here. Let's just ignore the question for now. Let's just use the list. Let's imagine I'm searching for number 27, okay? That's the number I want to find. And now visually I can see that's here at position 4 on the list, but actually that's how a computer works with a linear search. What a linear search does is it starts at the beginning of the list, which is position 0 here, and it compares 27 to the first value, which is 1. And it says, does 27 match number 1? Well, we know it doesn't. Okay, it doesn't match. So then what it does is it sequentially moves on to the next number in the list and compares that. So now it compares 27 to equal to 6. Do they match? No, they don't. So you can see the pattern here. Move along again. Compare 27 with 14. Do they match? No, they don't. So we move along again to 21. 27 equals 21. Do they match? No, they don't. So we move along to 27 here, and now we compare the two. And because we've compared them, we now know we found our match. 27 does match 27, therefore we know that 27 was found at position 4 within the array. Now, if it wasn't there, it would keep going through the list until it either finds what it's looking for or it reaches the end of the list, and it would then tell the user that it's not been found, okay? So that's how a linear search works, okay? It starts at the beginning of the list and works its way through. So this question here says, describe how a linear search algorithm works. So if I want to explain this in English, put it into steps. So the first stage is it starts at the beginning of the list and compares. So it compares the first item in the list at the beginning. Okay. If they do not match, sequentially work through the list, comparing each item. So it works for the list that way. So then you can say this will continue. I'll just put search ends when item in list is found or end of list reached. Okay, so there you go. So that explains in a nutshell how a linear search works. Okay, it starts at the beginning of the list and compares the first item. I'll put that to there. I'll put it over here. It's quite hard to read over there. And compares the first item. If they do not match, sequentially work through the list, so just like we showed before, going from one item to another, and then work the list, comparing each item. Search ends when item is found or end of list is reached, and that's how a linear search works. Okay, so that's that. Let's look at another linear search question. So this one here. This one says, state the comparisons that we've made when a linear search is being used to find value number 8. So we can see here that number 8 is at position 2. So let's talk through how this would work, okay? So first of all, we start at the beginning of the list, like we just talked about, and we would compare. So we'd compare 4 with 8, okay? That's our first comparison. Now, 4 and 8 do not match. So because of that, it will sequentially work to the next item in the list, compare this. So our next comparison, compare 7 with 8. Apologies for my writing, I know it's hard to read, but you know, the pen. And again, they're not matching, so again, it will sequentially work its way to here and compare 8 with 8. So the final comparison is compare 8 with 8. And as you can see, they do match, therefore it's done. And there are 3 marks there at each one of these comparisons, okay? So as long as you've written them correctly, that's where you get the marks, okay? Now, there are pros and cons to linear searches, okay? The kind of the pros of a linear search, generally speaking, they are easy to code from a coding point of view. They're relatively easy to code. easy to code. That's one benefit of them. And another benefit is list does not need to be ordered. Okay, and that's really crucial when we get to our next one, which is the binary search. So I'm going to close down OneNote and reopen it because OneNote does it sometimes. There with my OneNote, guys. There we go. So list. In that tab now. List does not need. List does not need to be ordered. Okay, so they're the pros. The cons though of it is it's not very efficient on large lists. So if you had like thousands of items in the list, it's going to take you forever to search through it. That's the major downside to it. Okay, it's highly inefficient. If you have a list of like a million different things in there, it's going to take so long to search through them. So pros of a linear search, the numbers don't have to be in any kind of sequential order. They can literally be in any random order, like a random deck of cards, which is great. But it just takes a long time to search through it when there's lots of numbers. Okay, lots of items there. So let's move on to the binary search. Okay, now the binary search works a little bit differently. So this is known as a kind of half and conquer kind of algorithm. So what it does, it actually finds the midpoint of the list and then goes from there. Now the first thing to note is the list must be in order. Okay, so if I kind of put up here binary search and say here list must be in order, that's crucial. Okay, and you get lots of questions with that where it says what is the criteria of a binary search, and it is that list must be in order. Okay, so as you can see here, this list, all the numbers are in sequential order from 1 to 35. And so therefore, we can do a binary search on this one. Okay, so to talk you through how a binary search works, you find the midpoint of the list to start with. Okay, so we look at the bottom list is 0, and the top of the list is 6. So 0 plus 6 equals 6. Divide that by 2, which gives me 3. So the midpoint of the list is position 3. So that's where we're going to start. Now we're trying to find position 30 here, or number 30. So what we do is we compare 30 with the item in the list, which is 21, and say, do they match? And no, they don't. 30 is obviously a different number to 21. Now, because this list is in order, we can say, well, is 30 bigger than the value or smaller than the value in that position? So 30 is bigger, is greater than 21. So what that means is everything now to the left side of the list, so this one here, this one, this one, and this one, they're all redundant because they're all going to be smaller than 30. So if it isn't in the list, it doesn't matter. We know that it's 30 is always bigger than 21. So there we go. So what happens next then is the bottom end of the list becomes to here and the top end of the list comes to here. We almost imagine the left side of the list doesn't exist anymore. So now we need to find the midpoint again. So 4 plus 6 equals 10. Half of 10 equals 5. So now we're at position 5, okay? So we're here and we're looking at value number 31. So we're now going to compare 31 to 30. Compare them. Do they match? No, they don't. They're different numbers. And we can then say, is 30 bigger or smaller than 31? Well, 30 is smaller. So we can discard this side of the list, move our pointers to here, top and bottom, and now we're at position 4. We can't really go anywhere else now. We're at the end of the list. So now we compare our final item, which is 27. So we say 27, does it equal 30? And no, it doesn't. So in this search, we can then deduce that 30 has not been found, okay? So that's how it works. If you're going to answer this question, you'll notice that it says the different comparisons. So you would write compare 30 with 21. That's the first comparison. The second comparison was compare 30 with, it was 31, wasn't it? Yeah, 31. And then the final comparison was compare 30 with 27. And there you go. Don't know why there's some zeros on there. Don't know where they came from. Let's get those. So there you go. So there are there's the three comparisons. Let's have another look at a binary search because they're quite tricky to do. So let's look at this question here. So again, we've got an array of numbers or a list of numbers. So let's work our way through it. So we're going to find the midpoint. So we'll start at the bottom of the list, which is 0, and the top of the list, which is 6. So 0 plus 6 equals 6. Divide by 2 gives me 3. So we're starting at position 3, which is 13. And we're trying to find value number 8. So the first comparison is we compare 13 with 8. Now, obviously, 8 is not 13, so we're going to carry on. But 8 is less than 13. So now we can discard everything on this side of the list here and the top of the list moves to this position. So now we're dealing with between 0 and 2. So we do the math again. 0 plus 2 equals 2. Divide by 2 gives me 1. That's right, isn't it? Yeah. 2 divided by 2 gives me 1, okay? So now we're dealing with position number 1, which is here, which is the middle of the list, okay? So now we're going to compare 7, which is in the position there, with 8. Because again, they don't match. So let's discard the left side of the list. And now obviously we're here at position 2 because there's nowhere else to go. So now we're going to compare 8 with 8. And obviously this is a success this time. This one works. So therefore it would output to the screen something like 8 has been found at position 2 or something like that. So that's basically a linear search and a binary search in a nutshell. Now, one thing to note is that you're ever in a position where you have to you're left with a point like 1.5, for example, after you do this plus this divided by 2, you always round down. So 1.5 becomes 1. I don't know, 2.9 would always become 9. Okay, so you always round down when you're doing this. All right, always round down. Let's have a look at some of these other questions. What property must be true about the binary search? Remember, it must be sorted or in a numeric order. And then this question here, state why a binary search is considered a better algorithm than a linear search. Well, it's more efficient. Or it's quicker because it uses less steps. I have seen a question in the past where it says, it gives you a list like this and it says, why would a linear search and a binary search not really make much difference? And basically it's because it's a small list. It's only really efficient on larger lists. A linear search is fine on like 7 items, but on a big list it's going to take a long time. So there you go, guys. That's your searching algorithms in a nutshell.